Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for choosing IT Pro TV, helping you learn everywhere you go. I'm your host, Zach Memis, as we continue on with CompTIA Net Plus OSI Model Part 2. Wes said we'd come back with Part 2, and here we are, and here's Wes. Good to see you, sir.
And let's roll at the endings. No, just kidding, guys. We wouldn't do that to you. That's right. More of that OSI model. Remember in the first part, we talked, we talked pretty extensively about the first few of the layers, right? I left you with not telling you what the layer 1 was about. But remember that the OSI model, the Open Systems Interconnection model, it goes back to 1984, if you will, by the International Organization of Standardization. Again, remember that it's an abstract 7-layer system that defines or standardizes the way we communicate across open systems, across computer networks. And we, in the last episode, we talked about the application layer, we talked about the presentation, session, transport, networking, and the data link layer, which is comprised of the LLC and the MAC, or the MAC layer. But we left you with a cliffhanger, just like Zach said. That's why we're back here. We left you not talking about the physical layer. So if we can go ahead and we can look at our document here that we have. Yeah, Zach?
Well, I'm just going to say, so the physical layer, this is the receiver, right?
You could see it this way.
I'm making it very simplistic.
Absolutely,
but you are the receiver if you're getting the physical layer here.
At this point, what we're talking about is there's no more addressing. Mm-hmm. What we have is the data link layer, the frame, essentially is placed on the media in its raw bit form. Right now, we're talking about the hardware, right? The electrical, the mechanical characteristics that are defined at this layer, and it is important to understand that this is where we talk about, if we're using Ethernet, are we using fiber optic media? If we're using fiber optic media, are we using the 10 megabit? Are we using 100 megabit? Are we using a gigabit? Are we using 10 gigabit networks? And usually when fiber optics today, you won't waste your time with the older, slower standards. It'll be a gigabit and beyond, 10 gigabit standards, right? But that's all where we talk about those binary ones and zeros that are actually going from source to destination. All right, so some of the technologies that we see here, Ethernet is one of those, DSL, ISDN, and let me step back and quit hitting you guys with so many acronyms, right? Digital subscriber line, DSL modems, right? They operate here at this layer. ISDN, right? The Integrated Services Digital Network. SONET, the Synchronous Optical Networking, which is what it's called here according to the American National Standards Institute, ANSI. But in the European nations, right, you have the ITU, the International Telecommunication Union, and what they call it is the Synchronous Digital Hierarchy. So SONET, SDH, right? Again, same technologies. That's just how they're standardized here in North America versus the European nations and stuff. Frame relay, ATM, right? We're not talking about automated teller machine. We're talking about the asynchronous transfer mode, right? So another networking communication as well. All happens here at this layer. When we talk about our base standards, right? 10 base T, right? 10 megabits baseband technology, T being twisted pair, right? Those baseband, but not baseband, but the base technologies, right? They're part of the physical layer as well. So you do have to know that, all right? Now, it's important to understand these things because you have to understand. Let's go ahead and go into a little bit more about, well, we'll say, for instance, how are these layers assisting each other? Well, let's talk a little bit about something known as encapsulation. Now, my head's kind of covering this one up, but we're going to start up here. We're going to start at layer 7, right? So we're going to say, hey, we're sending information, all right? When we send information, what's going on here is the application layer. Again, it gives us access to the network, right? And then an encapsulation happens, all right? Those of you out there that maybe have seen those little Russian dolls, I don't know exactly what they're called. Thank you, very good, Zach. Those little Russian dolls, right? We got one little Russian doll in a bigger, and then when you take them apart, right, you can sit there and stack them side by side.
And they all look like my grandmother.
Absolutely. Well, I don't know about that, but it does look like encapsulation. So apparently it looks like Zach's grandmother, and it's also a good analogy for encapsulation because that's what's happening, all right? What you have is something known as an SDU. An SDU is a service data unit, and that means that the application layer, right, our SDU or service data unit, excuse me, is basically going to be relying on the layer below it, all right? And when the layer below it services the layer above it, that becomes what's known as a protocol data unit, right? So keep that in mind that the application layer basically formats your data in a way that it can basically giving the application, or the application gives access to the network, right? Then we take it to the presentation layer, and the presentation layer adds its header to it, basically encapsulating it as well. Again, a little bit bigger of a doll, right? Now, it is assisting the application layer, right? So the applications layer's SDU, all right, now becomes the presentations layer's protocol data unit, PDU. But now, the presentation layer, we can't stop there, right? I mean, we got session establishment to happen. So now that it's got its format, we've got one doll and another, it's going to pass its information needing the assistance of the layer below it. So now it turns into a service data unit, and it hands its information requiring the services, I'm going to keep saying services of the lower level now in the session layer. The session layer treats that, basically that presentation layer, as its protocol data unit. So just understand that when an application needs a service from a lower application, that's considered a service data unit. When that lower layer actually provides that service, that becomes the protocol data unit. And then it hands that down, and that process happens all the way down to the physical layer. All right? And we go through this process of adding and adding and adding, right? Just adding basically those layers upon layers. The other way we could consider it is like an onion, right? What do you do? All right, well, if I was to pass this information, if we could take a look at that information right there one more time, notice that the physical layer down here at the bottom, those are your raw binary ones and zeros. Now, I want you to think about this. If we don't think about maybe the Russian dolls, maybe we'll think about an onion, right? I'm passing Zach over an onion. Now, we're not going to make Zach cry here on camera. We wouldn't do that to him, all right? But what he's going to do, his computer is going to peel off the first layer, right? In this case, it's going to be the data link layer, right? The data link layer is responsible for sending traffic between two physically connected machines, all right, across things like our switches. So he peels off that layer, says, hey, is this my MAC address? Yes, it's my MAC address. Okay, so let me go ahead and I'll process that a little bit more. Peel that off. Is this my IP address? Yeah, that's my IP address, so I'll process it a little bit more. And we keep basically peeling off the onions to the layer to the center part of that onion is your raw data. And that's what happens when I told you in the first part, where we essentially get layers 7 through 1 if I'm sending information, right? Because if I'm sending information, I've got my raw data, or data in general, and it goes down through the layers, little header after header is added on until we get down to the data link layer, that finally that MAC layer puts it on the network, right? Puts that information on the network. Once it's on the network, it's now in the format of those electrical or raw bits, right? Electrical impulses. As we process the information, each one of those layers, those encapsulations, right, become decapsulated. And that is up the OSI model. So you might hear the term down the stack or up the stack, all right? And for troubleshooting purposes, you also troubleshoot down the stack or up the stack, right? So the OSI model starts out, for a lot of people, it just starts out as theory, right? But then they get away from it and they say, oh, that's just theory. Well, it's not really theory, all right? And let me tell you why. When we talk about the devices that work at these layers, I got a little diagram that kind of show you some of the different components that operate at each layer, right? Here's why I tell you, figure out what layer of the OSI model is having the issue. Right? If I have a DNS issue, is it my DNS application that's having a problem? Well, if it is, it's at the application layer, and I know where that sits. Or maybe it's the fact that the IP address is wrong. Well, if the IP address is wrong, that's at layer 3, right? That's the network layer. So you can use the OSI model to figure out where the communication breakdown is happening. Right, some of the devices that you see, some of these higher devices, you will see some of these devices that operate at different layers as well too, and I'll explain that as I go. So for instance, you have certain firewalls that have to understand the session layer, they understand application layer information, right? They understand ports if they're doing stateful packet inspection, and that's what the NGFW is. It's next generation firewall. The next generation, it's our current generation, firewalls are very, very smart. They operate on just about every level of the OSI model. All right, when you get to the transport layer, this is where things like gateways happen. Now, I want you to understand that a gateway is a little bit different than what we're talking about when we say a TCP/IP default gateway. All right, the TCP/IP default gateway is just an IP address that basically connects you to your router and allows you to send traffic off your network. When we talk about a gateway device here, we're talking about something a little bit different. This is what allows you that interoperability between two similar systems. All right, so for instance, if maybe you were in a TCP IP based network, and in the earlier days, maybe you were still in an IPX SPX network, right? Well, a gateway device is actually translating between two dissimilar protocols so that we get the interoperability together. That's what we mean when we say a gateway device. Now, when we come down to the network layer, you're going to notice that we have things like routers. All right, well, routers, I want you to think about what they do. All right, if I need to troubleshoot, I can't send information off of my local network. Well, I do have to check things like the physical cables, right? We have to make sure that our network adapters are turned on, that the switches are available. But then we get to the network layer and we find out that maybe the IP addresses are wrong, or maybe there's a bad route in the routing table, right? I can tell where the breakdown is happening. And that's something that you should know, and not just outside of theory, but you should also take it into your networking career as well. So routers, IP addresses, routing protocols, right? That's what the routers basically operate off of. Layer 3 switches, all right? And why do we call it a layer 3 switch? Well, you're going to have to wait till I explain a switch, and then we'll come back to it, right? That's not too nice of me, right? A switch operates traditionally. Switching happens at layer 2. We talk about MAC addresses, right? We talk about forwarding frames between endpoints, right? They understand MAC addresses, but some switches, and a lot of switches today, are also layer 3 switches, because what does that mean? Well, it just means that they understand IP addressing. They can act like a router, and that's why they call them a layer 3 switch. You might hear the term router, and I've always thought that that's funny, but don't worry about it. It's not a bridge/router, if you will. It means it understands layer 2 and it understands layer 3. When we say a layer 3 switch, we're talking about one that essentially understands the functions of a router. All right. Now, switches, network adapters. Now you'll notice I've said before that some of these things operate at 2 layers, just like the layer 3 switch. It operates natively at layer 2, and it understands IP, so it operates at layer 3 as well. Well, guess what? A network interface card has a physical cable plugged into it. All right, but it also operates on MAC addresses, right? And it does encoding and stuff. So we do have some functionality that is happening at the layer 2 as well as the physical layer 2. As well, all right? So there are certain functionalities, and I went ahead and just put it at layer 1. Again, you'll see many different people will kind of debate where it should be. But it does have characteristics that share both. Now down here at the physical layer, a couple that people I don't think really would have any issue with is hubs and repeaters. See, a hub it's a really dumb device as far as network connectivity devices. It doesn't understand addressing. It doesn't make logical decisions like a router does. It doesn't even look at like a MAC table like a switch does and make sure it knows where to forward information. It is electrically hardwired to receive a signal on one port and then broadcast it out on all other ports. It's electrically wired that way. There's no logic, all right? Repeaters, what does a repeater do? Well, a repeater is a way to regenerate the signal. When a signal is getting to the end of its physical media, the maximum transmission distance, right? If it went any farther past that, then we get errors, we get communication errors, we get what's known as signal attenuation, and attenuation is just the progressive degradation of a signal as it gets farther and farther from its source. Well, you got a wireless repeater in your house? Well, you've got a physical layer device, right? Because what is the wireless repeater doing? It's receiving that wireless signal, it's regenerating it, and it boosts it out farther, so it thereby extends the length of the transmission distance, right? You have wired repeaters and you have wireless repeaters. These all operate on the physical layer. You also have things like modems. We'll talk a little bit more in other episodes about modems, but modem is just short for modulator-demodulator, modulation-demodulation. Right, it takes an electrical signal, it modulates it with a modulation scheme, and it sends it across an analog PSTN line, right? Physical public switch telephone network lines. And then on the other end, what happens? Right, the modem does the demodulation, and it removes the encoding, and it leaves the digital bits that are then delivered to the network adapter and processed by your computer, and back up the stack we go, right? So these are some of the things that you have to be aware of when it comes to the exam. All right, know what your layers are. Know the processing models, or how our computers process. Know what encapsulation is, right? Remember, encapsulation is just the process of one layer handing its information to be assisted by the lower layer. It basically puts it in this envelope, if you will, and it adds its data to it, and then the process repeats all the way till we get down to the switch and that MAC layer defining who can access the media, right? These are important things. Remember what layer of the OSI model things like switches operate on, things like routers, gateways, if you will. Understand what an application layer firewall is. You might have heard that term before and never understood what it meant. You say, well, we got an application layer firewall. What does that mean? It means a firewall, and that's your next generation firewalls that are smart enough to know that just because you tell me it's DNS, that firewall can look at it and say, I understand HTTP traffic, and that's not DNS, that's HTML in there. So nice try, but that's a web-based attack. It's smart enough to understand this, right? And you want to be aware of it, right? One of the things we talk about, TCP session identifiers, right? Those port numbers. Port numbers happen at the session layer. We want you to be aware of these technologies, and it certainly, you could spend an entire month in just the OSI model. But remember some of the basics. If you remember these basics, you're going to be doing well for your next Net Plus exam.
Oh, fantastic. OSI Model Part 2. And there's a Part 1. And you watch them both and you'll see that Wes has put together all this information for you to help you in the exam. And make sure you watch every single episode in the CompTIA Net Plus series and every other video in the course library. Hundreds of videos. And they're all designed to help you go further. And tell everybody you know about IT Pro TV. They'll be mighty glad you did. Thanks for watching. I'm Zach Memis.
And I'm Wes Bryant.
And we'll see you soon.
Thank you for watching IT Pro TV.